In the last video, we determined that 80 kilometers per hour is equivalent to 22.2 repeater meters per second. Now in this video, I want to talk about direct proportion, and I want to relate it to this example here. Now, if I was to have a greater number here instead of 80, let's say we doubled it to 160 kilometers per hour, that would change what it is in meters per second. And it would actually double it in meters per second. It would actually be 44.4 repeater meters per second. Now, this idea that it increases in proportion, we call that direct proportion. So the idea that if I double one, the other's going to double, and also if I halved one, the other would halve. If I halved this to 11.1 repeater, that would then become 40 kilometers per hour. So the idea is that they are in direct proportion. And we can express this with an algebraic equation. The general equation for a direct proportion is y equals kx. Now let's say that our x is meters per second and our y can be kilometers per hour. Now, we don't have k. That's what we need to find. So that's called the proportionality constant. And to find k, we need to substitute a value for y and for x. So we need to know a particular value of y that corresponds to a particular value of x. Up here, we know that when y is 80, so we've got 80 kilometers per hour, x must be 22.2 repeater. So we can substitute these values into our equation, and then we will only have k as the only variable, and we can solve for k. So let's try doing that. We've got y equals 80, k times by 22.2 repeater. So then to solve for k, divide both sides by 22.2 repeater, and we get k equals 80 over 22.2 repeater, which comes out to be exactly 3.6. And now we can rewrite this equation here without the k, because we know k is equal to 3.6. So we can rewrite it as y equals 3.6x. So what this actually means that if I have a speed in meters per second, and I want to convert it to kilometers per hour, I need to multiply it by 3.6. Now, if you check 22.2 repeater and multiply it by 3.6, you will get exactly 80. And this will work for any value. So if I've got any value for meters per second, I can multiply it by 3.6, and I will get what it is in kilometers per hour. Now we can actually graph this here. So I'm going to try and graph in, because this is just a straight line, a linear equation. So let's say down here we've got our meters per second, and then here we've got our kilometers per hour. Now, it's just going to be a straight line with a gradient of 3.6. So let's try doing that. So just be something like that. So if you had an actual grid paper, you might do it a bit more exact, plot in some points, but this is just a rough sketch. And what you would have, if this was, say, 80 here, 80 kilometers per hour, if this came over to here at that point and then went down, this would be 22.2 repeater. Because 22.2 repeater meters per second has to be equal to 80 kilometers per hour. And the slope of this graph, the slope here, is equal to 3.6. And that will always be the case for direct proportion. The slope is whatever the constant, the proportionality constant is. So whatever our k was. In this case, it was 3.6. For a different example, it will have a different value. But just for this one, we've got a slope of 3.6. And this is very convenient because we can just read off the graph. If it was drawn accurately, we could read off the graph for any particular value of meters per second and convert it to kilometers per hour, and vice versa, of course. So that was direct proportion, and next we'll be talking about inverse proportion.